Hey guys, another nice little video for you. So we're still awaiting test results and I don't know, being tortured at home. I would way rather be at school right now, so I'm sorry again. But let's just do a few quick other things just so we're not falling too far behind and then reminding ourselves that we'll go over all this when I get back. So I had mentioned the other day that we were talking about a few things. We said, like, you just have I that represents a square root of -1, and then you have I squared, and that equals -1. I to the third is equal to -I, and I to the fourth is equal to 1. So what happens is this is kind of, it's just cyclical. So what happens, I to the fifth is just going to equal I. And then I to the 6 is -1, and then -I, and then 1, and then it just keeps repeating. But sometimes you need to know something that's like maybe a little bigger than just finding the pattern. Like if I said, hey, what's I to the 76? And you would say, I don't flipping know. So if you ever need to find an I raised to an exponent, greater than being able to just look at a pattern, what you can always do is take your exponent and divide it by 4. So exponent divided by 4. So what happens is then you're looking at the remainder. So 4 things can happen, right? Because we're dividing by 4. If your remainder is 0.25, that means it's I. So 1 divided by 4 is 0.25, so that makes sense because I to the first. I to the fifth, 5 divided by 4 is 1.25. So basically anything with a 0.25 remainder, or decimal, I should say, not remainder. You get the idea, is I. If you have a remainder or a decimal of 0.5, that would be -1. Of 0.75, that would be -I. And if you have no remainder, or I should say no decimal, then that's just 1. And that makes sense because it's something divided evenly at 1. So let's say I did this one, I to the 76. You do 76 over 4. I have no clue what that is, so I'm grabbing a nice little calculator here. 76 over 4 is just 19. There's no decimal. So since there's no decimal, that just equals 1. So sorry, I'm at like weird angles here. Let me try to fix myself. So if I said, what's I to the 81st, you would say, oh, in my calculator, I'm just going to do 81 divided by 4 super quick. Sorry, I'm just doing it on my calculator right now. It comes out to 20.25. I really only care about what that decimal is. Since the decimal is 0.25, this is actually just equivalent to I. If I said something like, what's I to the 154th power? You would say, oh, 154 divided by 4. That gives me 38.5. I focus on the decimal of 0.5. If the decimal is 0.5, that's equivalent to -1. So I was kind of like, those ones are kind of quick. You don't really have to do a lot of work. It's just throwing in the calculator, knowing that you're dividing by 4, since it is a cycle of 4 different values, and then just knowing what to look for. So just those 3 or 4 remainders, 0.25, 0.5, 0.75, and then no remainder. So just as a heads up, there are a few of those on there. So then the other thing I want to just talk to you quick about today is division. Yay, how exciting. Division, quotients, whatever the heck you want to call it. Let me move this bad boy down. So what's going to happen is we can divide things with i's. Let's say it's something like that. But there is a rule that we never want the square root in a denominator. So what happens is, since I is representing a square root, we basically never want your answer can't have I in a denominator. Okay, so we need to take care of that. So there's a pretty easy way to take care of it. Oh, excuse me, I'm so very chilly today. So the way we can take care of it is we're going to multiply by Technically, this 3 is there, and that's great. I really want to take care of the I. So what I can do is multiply by I over I. So the reason I can do that is because I'm really multiplying by 1, right? Because something over itself is 1. But my main goal is I want to take care of the I in the denominator. So let's see what happens. 10 times I is 10I. Okay, that's not bad. When I do this, the I times the I is I squared. That's just going to give me -1. So that's the whole reason I'm doing that. So I'm multiplying by I because we know that I squared is -1. So 3 times -1 is -3. And then that's just my final answer. There's nothing else I can really do to that. And we would write it like that. So just as a heads up, I's cannot be in denominators. So we call that rationalizing the denominator, getting rid of that radical, aka that I, in the denominator. So you can just multiply by I to do so. So if I gave you something like 3 over 2I, you would say, "Ooh, don't want that because I don't want an I in the denominator." So I can multiply by I over I. Because once again, you're really just multiplying by 1. You're not changing the value. So 3 times I is 3I. And then here, I times I is I squared, which is -1. And 2 times -1 is -2. There you go, my friends. So those ones are a little bit more basic. I kind of like them. They're pretty quick. It's really just taking care of that I and making sure you never give an I in the denominator of an answer. So what can happen, it can't be that easy, is you might have something like this. Now you have a binomial on the bottom, but there's an I as a part of one of the terms. So I can't just multiply by I over I, because if I did that, then I'd have to distribute the I here, and that would be a big old mess. So what we're going to do is we're going to multiply. It's the same kind of idea. We're going to multiply by something over itself, so we're really multiplying by 1. But when you have two terms like this, you're going to take these two terms, the 2 and the 3I, and you're going to change the sign. We call that the conjugate. It's basically the same binomial with the opposite sign, and you're going to put that over itself. So what's in the denominator? Terms are the same. The only difference is if this is a plus, we change these to minuses, and these end up being the same thing. So we're going to distribute. You'll see the magic that's about to happen. So if I distribute this, I get 12 minus 18I. Okay, that wasn't bad. And then here, once again, you just know if you want to throw parentheses, but you're just distributing. So we end up with 4 minus 6I plus 6I minus 9I squared. Okay, so that wasn't that bad either. I'm just kind of rewriting the numerator there. So the whole reason we did that is because you see a negative 6I plus 6I, and those are going to cancel. So that's a delight. Once again, we don't want i's in the denominator. So you're probably saying, well, I still have an I squared, but we know that I squared really equals -1. So -9 and -1 would give me +9. And now I can combine this with the constant of 13. Once I get here, I notice I can't reduce anything. And that's what my final answer would look like. So really, it's an equivalent expression. It's just we are taking care of that I in the denominator. So once again, we call that multiplying by the conjugate. So you basically take what's on the bottom, but you have to change the sign. And the reason we have to change the sign is because we need one positive, one negative to cancel there. So it all kind of works out as a beauty. So let's try another one. So if I have 6 plus 5I over 2 minus I. Okay. So I look at this and I say, oh, can't have an I in the denominator. So remember, we're not actually dividing things. We're really just trying to simplify this. So what am I going to do? I'm going to multiply by, take these terms, change the sign. So it would be 2 plus I. Okay. And then we're just going to do a whole bunch of distributing and kind of see what happens. So in this case, in the numerator, now we have a little bit more. What do we get? 12 plus 6I, and then plus 10I, plus 5I squared. Okay, so just some distributing. I'll kind of take care of simplifying that in a second. In the denominator, I'm going to do the same thing. So I get 4 plus 2I minus 2I minus I squared. All right, so we've done the work. We just need to simplify. So what I see here is this I squared is really a -1, right? So this ends up being -5. and 12 minus 5 is 7. I can combine 6i and 10i to give me 16i. Okay, the bottom. So what should always happen is your i's are going to cancel. So that's the whole reason we do all these fun steps here to cancel those i's. I squared is -1. Just be careful because it's minus -1. So that actually ends up being +1. So just little things like that. 4 plus 1 is 5. And then I always check to see if you can reduce. But when I look at these three terms, they don't all have anything in common. And that would be your final there. So for today, it was just kind of an intro to that stuff. Once again, I do expect you to try stuff. So these are not off days, as unfortunately they are not off days for me either. I'm at home correcting everything, doing these videos for all my classes, having all sorts of fun. So I expect to see some effort. I expect when I give you some numbers, you're actually scanning them in because I want to see how people are doing and go from there. But the main goal for today, and I'll give you the numbers in the Google Classroom, is if you have an I raised to a power, kind of the power 1 through 4 is that nice cycle, and then it just kind of keeps repeating. So if something is larger than that, you're going to divide it by 4. You're going to look at the decimal, or if you think about it, like what's left. And then that will kind of be your hint as to what part of the cycle it is in. Is it equal to I, -1, negative I, or 1? And then we talked quick about division. So if you see things are being divided, but the main thing you're thinking to yourself is, when I see division or fraction, however you want to think of it, I cannot have I in the bottom in the denominator. How do I take care of that? So if there's just one term in the bottom, right? There's no pluses or minuses on either of these. It's just multiply by I over I. That kind of takes care of it. If you have more than one term in the bottom, so binomials here, you are going to change the sign. So the reason we do that is, once again, so you have that plus and the minus in the denominator for them to cancel. So that's the main idea of today. So in the Google Classroom, I will let you know what numbers you are working on. Reminder, you're doing your best, but you are trying something so that when I get back to you, you do have at least a little bit of a knowledge, and we can go from there. So have a good day.